Welcome to Intro2Astro 2024.
Hello, I'm Paridhi and I'm a senior pursuing computer science and engineering at Ahmedabad University. I spent the summer studying the TESS mission and its data sets as an undergraduate research program at my university. And I would also like to take it further for my thesis. I will be taking an session on Introduction to TESS. So the Transiting Exoplanet Survey was launched in 2018 and it is the first high-precision full-sky photometry survey. It aims to discover transiting planets orbiting the brightest and the closest stars across the entire sky. TESS takes images of around 200,000 stars every 2 minutes and millions to billions stars every half hour. Here's a video animation to show how the TESS satellite works. Just a second. So TESS monitors 24 by 96 degree strip of the sky called sectors for about 27 days using its 4 cameras. So this particular field of view is one sector, and for a particular hemisphere it covers 13 sectors before it rotates to cover the northern hemisphere. So some targets are covered for multiple times. Oh, oops. Yeah. And then we can also see some gaps here. So this is on its 5th year and it would be extended till September 2025 to cover the entire sky, and it is likely to cover like 400 times as it was covered by the Kepler mission. And TESS will continue to provide time series data for users on hundreds and thousands of targets. A small recap on the transit method, which was spoken about by Zina. So during the orbital motion of an exoplanet around its host star, the exoplanet periodically comes in a line of sight between the our satellite and the host star. So we see a, a dip in the flux or the brightness received from the particular star, and we look at these transit to detect for exoplanets. So these are the data products that we get from the TESS mission. So firstly, the full frame images. So the FFIs capture wide field images of the entire field of view. FFIs allow astronomers to monitor many stars simultaneously, providing a broad overview of region of the sky. And then we have the target pixel files, TPFs. TPFs contain pixel level information around the specific target star, enabling precise measurement of its brightness over time. And then we have the light curve files. So the light curve files contain flux time series data and are produced for each 2 minute and 20-second cadence data from the TPFs using simple aperture photometry. So today we will work with the light curve files, and we will look at a tutorial on how to work with it. So in this tutorial, we would see how we can access the TESS data and how we can utilize the light curve library to manipulate and access the TESS data to look for transits. So initially we have to make some installations, pip install light curve. It is not, we have to run it every time on Colab, but it is not necessary to do so every time on Jupyter Notebook. And we would also need, after we are done with installations, we would need to import 2 packages. One is the light curve package and the matplotlib that we would require to plot our data. Please uncomment this if you are using Jupyter Notebook. So these are some terms that we would come across in this tutorial as we use the light curve files. we can access the data products. So tick is basically an identifier in the TESS input catalog. So we can directly give the tick ID to the light curve package, and we can access those tick IDs. Uh, Light curve provides several functions we can use to search and download observations from Kepler and TESS missions, and it accesses the data from the MAST archive. I have embedded those links here. You can also see them for further reference. So we will look the sectors that our target was covered in, and the light curves that are available for that particular target. For today, our target is a confirmed planet was 48b, and we can see here that it was covered. So we have multiple light curve files available, and it was also covered in many sectors. And this table gives us many details about the sectors that it was covered and the year it was covered in. And by author, we mean the pipeline with which the data was processed and from which pipeline we are getting the light curve from, and the exposure time and the target name and so on. So once we have identified the sector that we want to work with, we take that particular part and we download that file, and we can just plot it using the LC plot. We can simply plot it with LC plot, and but I have defined such parameters to make our plots look much prettier. And we can already see that our transits are looking beautiful here, but we would require to further process it to make it more apparent. And yeah, so firstly we would normalize the data so that we have the data fluctuating around 1 instead of these values, these huge values. And by doing so, it helps us make comparison. It makes comparison easier between different light curves and to identify patterns and anomalies. So to do so, we just have to write this command lc.normalize, and we plot it. So now we can see that our data is fluctuating around 1. So by normalizing, what we do is we take the median value of that sector and divide every single point by that mean values. And these are some functions that the light curve package allows us to use. Sometimes our data might require further processing, and if there are long-term trends, we would require to use the flatten function. And if there are some data points that are scattering way too much from the data, so we would also use remove outliers. It totally depends on the data that we have, and it might be necessary to make such processings. One of the crucial steps that we usually take is the phase folding. So in phase folding, what we do is that we take multiple transits and we make periodic cuts. So as you can see, we have multiple transits here, and we make a periodic cut and we place those transits on those chunks on top of each other to build up more signal. Because the more data we have, the better we can characterize the light curve. And the shape and depth of the transit is also very crucial because it gives multiple properties about that specific planet. So what we do here is we take the orbital period of the planet of our target, and we take the epoch time, the time when we see the first dip, and using that we cut it and then we place it on top of each other. It is very crucial to get the right epoch time and the period. So suppose if we take the wrong time period, our data might be a little skewed and it would look something like this. And if we get the wrong period, it would not overlap correctly and we would get dips like this, which is again not correct. So it is crucial to get the right period and the epoch time. So we can get the epoch time and the period from the ExoFob website. So this is the exopop website where we can write the target and then make the search for it. So we will get many details about that particular candidate. So I can see that they have mentioned their period, orbital period here, and then we can also get the epoch time. So here we have to so as our time is in BTJD, barycentric Julian date, so we would have to subtract it with this offset. We have to subtract this value with this offset to get the exact epoch time. So after doing that, we can get that value, and we would give that value to the fold function, and it will automatically phase fold it for us, and simply we just have to plot it. So as we can see, the transit is a lot more apparent now than it was before, and uh, uh, sometimes we would also require to use binning, which makes our transits much more apparent. So we would use binning. So what is binning? Binning is basically to downsample the data and to get rid of noise and scatter, which eventually smooths out our data. And by bin, we have to define a bin width, so that can be of 15 minutes or 30 minutes. So for a particular bin, we take the values and we take the mean of it, and so this black dot is the mean of this particular bin. So it keeps all the trend of the data, and like it does not get rid of the trend, and it gives it reduces the scatter actually. So as we can see, if like for this plot, the bin with 15 minutes was taken. So we have a lot more clarity on how the plot is moving. But we were not, taking a bin width of 15 minutes or 30 minutes is a good idea. But if we try to take sizes that are too large, we would start getting rid of trends that we want. So we would not want to take a longer bin width. So so we pin the phase folded data, and after doing so, we get a plot that looks something like this. So now we can see like the tip is a lot more clearer at this point. We can see the shape it takes. So yeah, we have plotted our light curve together. So now the question is, how do we pick a tick ID for ourselves? So there are some few websites, the catalogs that we can take a look at. The TOI catalog. We can also download this catalog and choose the tick IDs that we want to work with. So the PC here means the planet candidate, and the CP means confirmed planets, and EB means eclipsing binaries. So we would like to work with the CP's confirmed planets or the planet candidates. We can also check the pipeline that it came from. And it also gives the epoch value that we require and the orbital period value. So we can directly access those values from here as well. And we can also find tick IDs from the exoplanet archives from this link. We can also we can like see the sectors that the particular tick ID our target was covered for. The more sectors it is covered for, the better it is. And we can also look at public comments, so like the comments that they have for a particular target, which would also help us for our processing. And we can do the same here on the exoplanet archive. And then we may also use the exopop website to find more details about the same. So we might also need to look at the visibility and the brightness. So the higher the value it is, the better it is for us. And then we can also look for the files that are available for that particular target. So once you have selected those, you can directly run it on the using the light curve package. So so there is no such assignment specifically, but here I have listed out how to get the tick ID. So I would like you all to try it out for yourself and share about it on the Discord. And I have also given some links to the tutorials that one can use to access different data products or that comes from the TESS, and these are very detailed tutorials and you can learn a lot from them. So I would also encourage you to try at least one tutorial from these and also share about that, what you learned from it. So yeah, that's all from my side. I would be answering your questions if you may have on Discord. Thank you.
Register now on bit.ly/intro2astro 2024.